grade 7, and welcome back to Solving Equations. This is our second look at it. And today we're going to focus on two situations we haven't seen yet. In one, the thing that's being subtracted in our equation is the variable itself, as opposed to something being subtracted from the variable. The second one will be what if we are dividing by the variable, and it's not the variable that's being divided? And then finally, we'll take a look at when we combine both situations. So we'll begin with a simpler situation here. Here's our basic equation, 6 minus f equals 2. And what makes this different is that we are subtracting the variable itself. So if you think back to the weight scale, there isn't really a great way to demonstrate that physically on a weight scale. So we have to think abstractly in terms of the math itself. But if we don't like this, if we're not sure to handle this subtracting of an f, we can undo it by using the reverse operation, which of course would be to add f. But whatever we do to one side, we must do to the other. So here I'm indicating my intention to add an f to both sides. Well, if I start at 6, I remove f from it, whatever it might be, and then add it back again, well, I'm just back to 6. And on this side, I'll have 2 plus the f that I added. Now this looks more like problems we're used to. And yes, we need to get rid of these 2 extras sitting on the right side of the weight scale now. So we'll take 2 away from both sides, which will leave us 4 here, and f here. And so we have a solution. And let's remember to get into the habit of always checking if we were right. So I'm going to just quickly rewrite the original equation up top, substitute my value for f into the equation, and check that it does indeed come out to be true, which you can see it does. So let's take a look at that now with a slightly more complicated situation where we have more than one operation and need to use reverse bedmass. So this might catch a few of us a bit by surprise, might seem a bit odd. But the problem here is we're subtracting 3y. And this is not something we've been used to doing up to this point. And we can think of this right now as a stack of those little boxes. If you think back to our weight scale, we would have these boxes on one side, and you can just think of it as a stack of boxes called y, sitting over here together, but they're being subtracted, almost as if a helium balloon were pulling them upward. And we're just not comfortable with how to handle that. But we can undo it. We can get rid of this minus 3y by adding 3y to both sides. In other words, adding such a stack to both sides. So we'll indicate that here by saying I'm going to add 3y to both sides of my equation. Well, then here I'm left with just 18 once again. And on the right-hand side, I have 3 plus 3y. So we began by managing this subtraction first, if you think about reverse bedmass, but now we have an addition and we have a multiplication. And again, reverse bedmass says deal with the addition first. So let's take that 3 away from both sides, and now I'll have 15 equals just the 3y. And this we're quite used to handling at this point. We're going to divide both sides by 3, and we get 5 equals y. Now I am somewhat running out of room here, but perhaps I will take this one and I'll just verify it up here. So remember, I have to rewrite my equation. 18 minus 3y equals 3. Substitute in my value for y. So that's 18 minus 3 times my solution of 5, and that has to come out to 3. I'm no longer isolating a variable, so I'm back to normal bedmass, and I deal with that multiplying first. And I think we can see that 18 minus 15 will be 3. We'll have an equality, and I'll leave it there so I don't run out of room for my next problem. So here's one more like that. I'm going to go through it fairly quickly, but I do really encourage you to pause the video, try it yourself, and then see how you did. I'll run through it fairly fast, so when you unpause, you can just see the solution. So I'll begin by adding 5y to both sides, which leaves me with 42 equals 12 plus 5y. I'll subtract 12 from both sides. 30 equals 5y. I'll divide both sides by 5, and 6 equals y. And then to check that, I'll try to squeeze it in over here. We have 42 minus 5y equals 12. Throw the solution in. 42 minus 5 times 6 equals 12. 42 minus 30 has to equal 12. And that's exactly what it comes out to. And so once again, we were right. Okay, so that's when the variable is being subtracted. Now we want to take a look at how do we handle it when we're dividing by the variable, as is the case here. We're dividing by q. Well, we don't like that situation where we're dividing by q because we haven't seen it before, but we can get rid of it by using opposite operations, so you guessed it. We're simply going to multiply both sides by q, and that will leave us with 30 on this side and 5 times q on this side. This we can undo, this multiplying by 5, by dividing both sides by 5, which leaves us that 6 equals q. And then a very quick check. 30 over q needs to equal 5. Substitute in the 6 for the q, and yep, we got it. So this solution was correct. Q has a value of 6. Now let's look at another situation that's similar, but involves more operations. So that's this one here. And again, please pause it, write this down, and do your best at it. And then feel free to come back and see the solution. Again, here we are. We have a division and we have a subtraction. And we're in the world of reverse bedmass. We're going to deal with the subtracting first. Reverse operation says to add that 6 then. So that leaves me with 36 over q equals, I'm just going to put 9. The 3 plus the 6 is 9. And now we're very similar to this situation, and so we can just go ahead and multiply by q, which leaves us 36 equals 9 times q. And then to undo the multiplying by 9, we divide by 9, and we end up with 4 equals q. And for space reasons, I think that I will check my solution underneath. So again, rewrite 36 over q minus 6 equals 3. Substitute in your solution. We're in forwards bedmass because we're not isolating a variable, so this says 9 minus 6 has to equal 3. And I think we'll see that indeed that's exactly what this equals, and so we had the right solution. And this brings us to our third part, which is combining both of these. So we'll do one of these over here. And again, go ahead and give it a shot with what you've learned so far. Pause the video, try it, and then see how you did. I'll do this solution fairly quickly again in the interest of time. But we're subtracting our variable, which we don't like. We can sort of see this as just one entity. It's not quite a stack of y's like we had over here, but it's a portion of something. But we can treat it as one stack, and we can move it over to the other side. So I'm going to add 45 over m to both sides. That leaves me with just 47 on this side. And it leaves me with 38 plus 45 over m on this side. Again, using reverse bedmass, reverse operations, I will take 38 away from both sides. And that leaves me with 9 equals 45 over m. And now I can multiply both sides by m because I don't like this division by m. And so then I get that 9 times m equals 45. And now I can divide both sides by 9 to isolate the m. And I get m equals 5. I am out of room on this page, but you know now that you would take that 5, substitute it into the original equation, and check that everything came out equal. All right, so today's document will have the problems of this nature in it. Give them your best shot. Go back through the video if anything's challenging. Also, feel free to send questions my way, and I wish you the very best with it. Can you see? It's just that easy.